So this is our last lesson on solving sinusoidal word problems, and you guys have done word problems with polynomials so far, so you have used your calculators to be able to do this. You're going to need your calculators close to you again. We're going to be using them for the next two examples. This isn't a very long lesson. The other one was long. This one's quite a bit shorter. I need to make sure that you have your calculators in radian mode. So because my other calculator was not so great, I decided I was going to use this one, so bear with me. You can see my finger. This is super high class technology right now, guys. Like, you can see my hand. So we're going to press mode. I didn't like that the other one you couldn't see what I was touching, and I wanted you to be able to see. So I can go down arrow, and I'm going to go on radian, and I'm going to hit enter if it wasn't on radian. And then I can go second mode anytime I want to get out of something, because that quits me in whatever I'm in and puts me to my main screen. So instead of you viciously hitting clear like 8,000 times when you're stuck in like a graph or something like that, and I see you all doing it, and you're like, yep, that's totally me. I was like that in high school too. Then I learned about this lovely quit button. It's crazy. So you go second and then quit. And you'll always go back to your main screen. Isn't that amazing? Okay. So I need to be in radian mode, so make sure you're there. So we'll go back to the notes. So this one here is the height of a pendulum, h. So h is in inches, and h is always my y. So it will always tell you what something is. So we know that we're going to put in here that height. Wow, it's noisy. Height is in inches. So if I see anything in inches, I know they gave me height, and that equals my y variable. Very important. So the height of the pendulum, h in inches, above a tabletop, t seconds. So t, if you look at my equation, is where x normally is, right? So t is seconds. So we have h, which equals height in inches, t, which equals time in seconds, and that's my x variable. Very important that we know which variables are which. So let's try this again. The height of a pendulum, boom, boom. The height of a pendulum, h in inches, above the tabletop, t seconds after the pendulum is released, can be modeled by the sinusoidal function, this. Okay? They want us to determine the pendulum height. So they want us to find the pendulum height, which is y. So they want us to determine the pendulum height at the moment of release to the nearest tenth. Most of you guys are not looking for rounding rules when I'm marking, so I know you need to look. Nearest tenth. Tens have 1 0, so that's 1 decimal place. Hundreds, so the hundredth has 2 zeros, so 2 decimal places, okay? So the moment of release, the moment you release a ball, what is time? What is the time? The time is 0. So they're saying when time equals 0, which is actually when x equals 0, or t in this equation, right? But x in your calculator, what is h? So we can literally write this into our equation. So if they ever give us t, we can just plunge it right into our equation. It's really easy. When they give us h, we're going to need our calculators, okay? Well, we're going to need our calculators to do a special method. But when they give us t, we can just do algebra. So we're going to have h equals 2 sine, bracket 3.14 times 0 plus 1.57 plus 5. So h equals 2 sine, 3.14 times 0 cancels out, so I get sine 1.57 plus 5. Now, I cannot do that in my head, and neither can you. So if we just have something missing like that, we can type it into our main screen. So we're going to type in 2 sine 1.57, 1 decimal, 57, close bracket, plus 5. enter. And so to the nearest tenth, so we look at the 9, which is in the 10th spot. We look to the right, it's a 9. So the 9 is going to become a 10. So it's going to become a 0, and then the 1 is going to go to the 6. So it's going to be 7 decimal 0. So H equals 7 decimal 0, and H is in inches. And you have to put the decimal 0 if it says to the nearest tenth. If you put 7, you didn't round to the nearest tenth. And then we also have to write a sentence. So it says determine the pendulum height at the moment of release. So the pendulum at the moment, pendulum height at the moment of release was 7 decimal 0 inches. I promise in real life my printing is much nicer than this. So if you've been in my classes, you know that it's not this messy. If you don't believe me, go to the filled in version of the notes and you can see my actual printing, because I don't feel like you would believe this, but my printing is actually very nice. Okay. B. B says determine how long, so they're making us find to T, how long the pendulum takes to go from maximum height to minimum height to the nearest second. So this is what I need you to know. When it goes from max to max, that's one period. That equals the period, right? If it goes from min to min, that equals the period. If it goes from max to min, we need to take the period. And what do you think we should do with it? Divide it by 2, because it's half of a period. Okay? So we need to find the period. How do we find the period when we have an equation? We just did this in our lesson this week. The period is 2 pi divided by the b value of an equation. Remember? So now we're going to get 2 pi divided by 3.14, which equals 2 pi, second little roof symbol, divided by 3.14. Also, if you don't know how to do fractions in your calculator, you can get a fraction to show up if you use the fancy new ones. And I know I've taught you this before, but if you forget, you can go alpha y equals, and then hit enter. And then you get a fraction. So you can literally type it in the way it looks. 2 pi on top divided by 3.14. So if you ever have a fraction and you don't want to do brackets and you have the newer calculators, alpha y equals enter. Okay? So now I have 2.00104429. That's the period. I'm going to need to divide it by 2 because I need half of the period. So it's going to be 1. Don't know what's happening. Oh, this is technology at its greatest. In my own classroom, I have an actual calculator that pops up on my screen. It's so much better, and I can see you in real life, even better. So here I get 2.00, and then I have to take that and divide it by 2, and I get 1 because it wants to the nearest second. So 1 second. So it says, how long does the pendulum take to go from a maximum height to a minimum height? So we have to write a sentence. The pendulum takes 1 second to go from the maximum height to the minimum height. And then here it wants you to determine the maximum height of the pendulum. So to determine the maximum height of the pendulum, you do D plus the absolute value of A. So in this case, D is 5 plus the absolute value of 2, which equals 7 inches. So I'm going to get the maximum height of the pendulum is 7 inches. And this one wants us to determine the minimum height. So we're going to go D minus the absolute value of A. So it's going to be 5 minus the absolute value of 2, which we get from the equation, which is 3 inches. So the minimum height of the pendulum is 3 inches. Then they want us to determine the range of the pendulum. So we're going to go, normally it's y, but what is y in this equation? It's h. So I'm not going to use y, I'm going to use h. H such that 3 is less than or equal to h is less than or equal to 7 her, because I'm giving the height restrictions. Now we need to determine the time to the nearest tenth if it takes the pendulum to reach 6 inches. So they gave us h. They gave us h. So they gave us y. When they give us y, we have to do a two-step thing. So we go y equals, our y1 is our first equation. So our y1 is the equation from the top. 2 sine 3.14t plus 1.57. So this is just from the top of the page, plus 5. And then our y2 is the height they gave us, which is 6. And then we go second button, trace button. And we find out where they intersect whenever we know the y and not the x. Intersect. And then we go enter, enter, enter. So we go enter 3 times. So let's see this on my handy dandy calculator I have. So we're going to go into our y equals. We're going to clear it. Then we're going to go 2 sine 3.14x plus 1.57, close bracket, plus 5. And in our y2, we're going to have the number 6. We need to go to our window and make an appropriate window. Well, we know that this graph repeats itself horizontally at 2 seconds, right? So we're going to start at 0, because 0 would be 0 seconds, and it repeats itself every 2. So I'm going to double it and say 4. So I look at the period and I double it. So the period was 2. I'm going to make my x max be 4. My y minimum is 3 and my y maximum is 7, because that's for my range. So I'm going to go below it. So I'm going to go 0, and so below 3, I'm going to put a 0, and above 7, so I'm going to leave it at 10. And I'm going to press graph. And I have to be able to see the intersection. Okay? So it says determine the time to the nearest tenth it takes the pendulum to reach 6 inches in the first second. So I have 4 seconds here. So maybe I'm going to reduce my x max to 1 second because it has to be in the first second so that I only see that intersection. Well, there it is. And I go second, trace, which is calc, number 5, which is intersect, and I go enter, enter, enter. And I get 0.3337561 and y equals 6, which is good, but I only care about the x. Oh, I made that go away, sorry. Enter, enter, enter. If you want to get it to show up on your main screen, you can go to your main screen. So you go second quit, and you just press X, because that's what the answer was, X, and enter. And it'll make it that X pop up on your main screen after you found it. So we need it to the nearest tenth. So that's 0.3. So I'm going to get x, which is t in this case, sorry, t equals 0.3 seconds. Because height is in, or time is in seconds. So determine how long to the nearest tenth it takes the pendulum to reach 6 inches in the first second. It takes 0.3 seconds for the pendulum. I'm literally just rewriting what they typed to reach 6 inches in the first second. Okay, now here it says determine the height to the nearest whole number when the pendulum is at 2.5 seconds. So they gave me t. So only if they give me h do I need to do any fancy crazy calculations. If they give me t, I can just fill it into the formula. So the formula is h equals 2 sine 3.14 times 2.5, so that goes in for my t, plus 1.57 bracket plus 5. So I'm going to go my main screen, not my y equals 2 sine 3.14 times 2.5 plus 1.57 close bracket plus 5. Enter. And I get 5.00, and they went to the nearest whole number, so that's 5. And h equals 5, and h is in inches, so it's 5 inches. We go to write our sentence. Determine the height to the nearest whole number of the pendulum at 2.5 seconds. The pendulum at 2.5 seconds is at a height of 5 inches. One more question. So we have a whole new one. The height above the ground of a Ferris wheel on a Ferris wheel can be modeled by the sinusoidal function h equals 6 sine 1.05t minus 1.57 plus 8. H is the height of the rider above the ground in meters. T is the time in minutes. So T is in X spot, H is in Y spot. So here it says, determine the initial height of the rider to the nearest whole number above the ground. Initial height means initially. And when we read initially, that's t equals 0. And when we know t, we can just type it into our equation. So h equals 6 sine 1.05 times 0 minus 1.57 plus 8, which gets us h equals 6 sine, this cancels. Negative 1.57 plus 8. And remember, your calculator needs to be in radian mode, guys. So if it isn't, you're going to get it wrong every single time. So on our main screen, because we know T, we're going to go 6. Look at how my hands look like I'm 90. I need a pedicure. I mean a manicure. Pedicures for feet. My hands don't look that bad, but in this, it just look terrible. And a lot of hand washing, right? Okay, sorry. I sidetracked. So we get 6 sine negative 1.57, negative, not subtraction, negative 1.57 bracket plus 8. And you get 2.00000, whole lot of zeros. And it wants it to the nearest whole number. So that's no decimal places. Wow, I just took pictures. I didn't mean to. All right. So that equals 2. And its height, so it's 2. And the height is in meters, so 2 meters. Don't want to write the E. Okay. So it says determine the initial height of the rider above the ground. The initial height of the rider above the ground is 2 meters. Now, I want you to determine the minimum height of the rider, and then the maximum height of the rider comes next. So the minimum height, we do is D, which is 8, plus the absolute value of A, which is 6. So I get 8 plus 6, which is 14. And it's a height, so it's in meters. So we write the minimum height. Oh, I just did maximum. Dagnabbit. Minimum is a minus sign. 8 minus 6, which is actually 2 meters. Okay, let's try this again. The minimum height of the rider is 2 meters. Now let's do the maximum, which I already did by accident above. The maximum equals 8 plus the absolute value of 6, which equals 8 plus 6, which equals 14 meters. So they get on the ride at 2 meters, and they go to a height of 14 meters, and they go back down to 2, up to 14, down to 2. It's just a Ferris wheel, right? So now we have the maximum height of the rider is 14 meters. I'm going to tell you right now that my most hated ride in the whole entire world is Ferris wheels. They go so slow, and then they stop you at the very top, and I'm super afraid of heights, and I hate Ferris wheels so much. Like, I'd rather go on something super fast that makes me want to puke than go on a Ferris wheel. Despise Ferris wheels. I went on the Mickey Mouse one in California Adventure, and we went on the one, not the one that stayed straight. We went on the one that zoomed around, and that was actually the worst ride I've ever been on. I thought just a plain old Ferris wheel would be worse. Nope, that was way more terrible. It was probably the hardest one we rode in either California Adventure or Disneyland last year. So, if you want a crazy ride, go on the Mickey Mouse Ferris wheel. Not the one that stays straight, but the one that zooms around. You can YouTube it if you don't know what I'm talking about. Okay, what's the range of the heights of the rider? So the range, once again, my y is h, not y, so I can't use y, I have to use h, because h is my variable, not y. So h such that the lowest they can go is 2, less than or equal to h, less than or equal to the highest they can go is 14. H-E-R. How long does it take to the nearest whole number for the Ferris wheel to make one full revolution? One full revolution is from minimum to minimum. And what's minimum to minimum? Min to min is a period. So they literally are just a fancy way asking you to find the period. And the period from an equation is period equals 2 pi divided by the b value. So in this case, it's 2 pi divided by 1.05. And 2 pi divided by 1.05 in your calculator is 5.9839, etc. And they want it to the nearest whole number, so it's 6, and time is in minutes. So they want to know how long it takes for the Ferris wheel to make one full revolution. It takes 6 minutes for the Ferris wheel to make one revolution. At what times in the first revolution does the rider reach 8 meters? So they're giving us h. And when they give us h, remember what we have to do. y1 is our original equation, 6 sine 1.05t, or x in this case, minus 1.57 plus 8. So we would do an x in our calculator. And then our y2 equals 8, and then we have to find out where they intersect. So, okay. So we're going to go on. We're going to go to y equals, closer, clear, clear. And we're going to go 6 sine 1.05 xt theta n button minus 1.57 bracket plus 8. And in our y2, we are going to put 8. Our window, our x minimum, we're going to use 0 because the time would be 0. And our x max is the period, because it says one full revolution, and it makes one revolution in 6 minutes, so my x max is going to be 6. So I always base my x max on my period, how long it takes to do one revolution. My y minimum is 0, so it goes from 2 to 14, this Ferris wheel, so I'm going to go from 0 to 16. And it wants to know what times, so there's going to be 2. It's going to cross it at 8 meters on the way up and 8 meters on the way down. So we're going to do it twice. Second, trace 5, move over to this one, and bounce down onto this line and get there faster. Enter, enter, enter. So 1.49, and it wants it to the nearest tenth, so I'm going to say 1.5, and then I'm going to do it again. Second, trace 5, and I need to move over. I'm going to pop down onto this line so it goes faster. So I pop down onto that line so it went faster. And I'm going to arrow all the way over. I don't know if my hand covered it up last time, sorry. So you move all the way over to this one, enter, 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 and you get 4.5. So I'm going to get 1.5 minutes and 4.5 minutes. That's meters. I need to erase that. 1.5 minutes and 4.5 minutes. And then I need to write a sentence. At what time in the first revolution does the rider reach 8 meters? The rider reaches 8 meters at 1.5 minutes and 4.5 minutes in the first revolution. What is the height of the rider at 4 seconds? So now they're giving us, they want the height and they're giving us t. And when they give us t, we can just fill it right into the formula. So h equals 6 sine 1.05 times 4 minus 1.57 plus 8. When you type that into your main screen, you get 10 decimal, my goodness, 10 decimal 9374 meters. So what is the height of the rider at 4 seconds? The height of the rider at 4 seconds is, it's the nearest tenth, 10.9 meters. So this back here should be 10.9 meters. Okay, because I don't think you believe me, and I'm not sure if you'll go look at my notes that are pre-typed because you just watched all of this, I'm going to show it to you because I don't think you believe how neat I am. Look at how neat I really am in real life. So neat. Look at that. Way neater. Oh, and you want to see something else really cute? These are my children. When they were in dance like 3 years ago. Now one's in gymnastics and the other one likes to swim and skate. And neither of them are going into dance next year. But look at how cute they were when they were in dance. And the one in her hip hop outfit, she was so mad because she just wanted to be in a pretty princess dress. But still so cute. London and Isla, aren't they adorable? I hope you guys have a great week and know that we miss you. And once again, if you have any questions or you need help with anything, please contact us.